of orbitals in the atom. Different shells and subshells have different energy levels. So the electrons are filled to these orbitals depending on their energies and other factors. The electron filling into the orbitals of different atoms can be described using some rules. The Aufbau principle. The German word Aufbau means building up, and this term has traditionally been used to describe the manner in which electrons are assigned to orbitals, as we carry out the imaginary task of constructing the atoms of elements having successively larger atomic numbers. This principle states that the electrons are added one by one to the various orbitals in their order of their increasing energy, starting with the orbital of lowest energy. The increasing order of energy of various orbitals is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. How does one remember such a big sequence? To make it simple, we use a method to write the increasing order of the orbitals. Starting from the top, the direction of the arrow gives the order of filling of orbitals. Notice that the s orbital always has a slightly lower energy than the p orbitals at the same energy level. So the s orbital always fills with electrons before the corresponding p orbitals. Let us now explore the Pauli exclusion principle. One can think of an atom as a very bizarre house, with the nucleus living on the ground floor, and then various rooms, orbitals, on the higher floors occupied by the electrons. On the first floor there is only one room, the 1s orbital. On the second floor there are 4 rooms, the 2s, 2px, 2py and 2pz orbitals. On the third floor there are 9 rooms, 1 3s orbital, 3 3p orbitals and 5 3d orbitals, and so on. But the rooms aren't very big. Each orbital can only hold 2 electrons. The Pauli's exclusion principle states that no 2 electrons in an atom can have the same values of all the 4 quantum numbers. If an electron in the atom has the 4 quantum numbers n equals 1, l equals 0, m equals 0, and s equals plus half, no other electron may have the same 4 quantum numbers. In other words, we cannot place 2 electrons with the same value of s in a 1s orbital. Each orbital can accommodate a maximum of 2 electrons only if their spins are of opposite direction. So it can be concluded that every subshell holds a maximum of 2 electrons in an orbital. This is shown in the table here. Now we shall study about Hund's rule of maximum multiplicity. When there are degenerate, equal energy orbitals available, electrons will enter the orbitals one at a time to maximize degeneracy, so that orbitals will have same energy levels. So the electrons enter the orbitals only when all the orbitals are half filled and then pairing up occurs. This is the rule of maximum multiplicity. Where there is a choice between orbitals of equal energy, they fill the orbitals singly as far as possible. This filling of orbitals singly where possible is known as Hund's rule. The 3 electrons that are filled into the 3p orbitals can be represented in 2 different ways, as shown here. The second arrangement is correct, as it follows the rule.
Starting to feel it? Now go master it with Maski.